So welcome back. We're going to cover section 2.3, other types of graphs. So the first part of this section, we're going to just kind of show you some different types of graphs. They're all pretty straightforward, but we'll describe some of the rules that are just good ideas in creating these graphs. And at the end, we'll play a fun game where it's like we're going to look at a whole bunch of different versions of graphs, and you get to decide what's wrong with it. So we're going to play that game in a second. So the first type of graph is a bar graph, and bar graphs can either be horizontal or vertical. And I think they're nice because they give you a good picture of what's going on for categorical or qualitative data. And you can also do a compound graph, like here on the right is a compound graph where you have both men and women broken up into categories. I think the most useful bar graph I use is for FPL. They let you compare your energy usage, like for the month of March from last year and this year, and you can see whether or not things are out of control because you're staying home and spending way more money on air conditioning. Okay, so again, yeah, bars can be horizontal or vertical, and the data can be categorical or qualitative. You have anything else I should say, Karen?
No.
Okay. Oh, and good, we wrote down compound bar graph. Perfect. Okay, the next kind of chart is a Pareto chart. And that's kind of the same thing as a bar graph, but they always go from high to low. Okay, so it's always going to be sloping down, and there's no space between the bars. So those are the two key features of the Pareto chart. Okay, so the next kind is a pie chart. And a pie chart, the percentages should be adding up to 100%. And 100% should equal 360 degrees. So the calculation goes something like this. You take the frequency divided by n, which n is the total number of categories. Is that right? Times 360?
It's the total frequency.
N is total frequency. Okay.
Yeah.
And f is the frequency for the particular
category.
Okay. And so, for instance, if we do potato chips up here, we see that the frequency is 11.2 million. The total frequency is 30 million. So you take 11.2 divided by 30, and then you multiply that by 360 degrees, and that gives you 134 degrees. So that means that the potato chip slice should be 134 degrees wide. Okay. Another way to look at this is you can calculate the percentage. Well, the percentage is just f divided by n times 100. So again, we take 11.2 divided by 30, and we multiply by 100, and that gives you 37.3% potato chips. Sound good?
Yeah, so you would have to do those two steps for every category.
Right.
And then that would give you your full pie chart.
Cool. Okay, a dot plot is pretty straightforward too. You just put a dot every time that value occurs. This is the number of named tropical storms each year from the years 1971 to 2010. And you can see here that most years we have between 5 and 10 storms. It's not uncommon to have between 10 to 15, but it's very uncommon to have more than 15, 16, let's say. And this largest value is what we call an outlier. A year of 28 storms is just ridiculous. Any idea when that happened, Karen?
I don't know.
Yeah. Okay. So there's used to show distribution of data values, and you can see if there are any extremely high or low data values. So a low value would be like 4, and a really high one would be anything over 16, I would say. Okay, so then another example is a time series charts. So these represents data that occur over a specific period of time, used to look for trends or patterns. Let's see here. So an ascending line indicates an increase over time. Descending indicates a decrease over time. And a line that is steep over a specific time period indicates a rapid increase or decrease over that period of time. I can say that some of our FGCU students work for Hertz now, and they do this sort of these time series analyses for demand in different markets for Uber and Lyft. I don't know, just going off on a tangent there. You can also use compound time series charts. That's where you just put multiple time series charts on the same chart. Here we have for men and women. So this is the elderly in the US labor force. And I guess the trend looks like it was going down until about 1990, and now it's going up for both men and women. I bet you it goes even further if you were to look at 2020. Anything I should say here, Karen?
Just that when you have like multiple ones on the same graph, it just kind of lets you easily compare the slope of the line. So you can see like which one was maybe increasing more or decreasing more compared to the other.
Cool. I'm gonna let Karen talk about stem and leaf plots.
So I think most people have seen a stem and leaf plot before, but basically we're just going to make like a little table where we have a stem column and a leaf column, and it's going to describe our data. So the first digit is the stem, the second is the leaf. So when you make your table to figure out your stems, you just want to look at like what your numbers range from. So they go from 2 up to the largest one is 57. So you would want to have stems that range from 0 to 5. Okay, and you don't want to skip any numbers. So even if you were missing one, you wouldn't want to skip it. And then the leaf part is going to be the second digit in all your numbers. So for the whole number 2, we have a stem of 0 because we need to write it as 2 digits. So the leaf part would just be 2 for that. Okay, then you go through and you look for numbers that start with 1. So we see that there's a 13 and a 14. So that means you're going to put 3 and 4 in the leaf row for 1. Okay, and sometimes just depending on the properties of the chart, you might put a comma in between the numbers, but Connect does not have you put commas. They just have you put like a space in between the numbers. So you would just do like a 3 space 4. And typically you want to put them in order from least to greatest.
Okay.
Then let's see, for the 20s, we have 25, 20, and 23. So you would do 0, 3, and 5. That would represent those 3 numbers. Then there's 31, 32, 36. So you put 1, 2, and 6 with the 3. And then for 40, there's nothing. Now, if you were just doing this chart by hand or on paper, you would just leave that blank, and that would tell you that there's no number in the 40s. But for Connect, you need to put a capital N in that spot. And it does tell you that in the directions of the question, but most students don't read the directions and they just naturally leave it blank and it marks you wrong and it doesn't tell you why. So if you are getting marked wrong on your stem and leaf plot questions, that might be something to look out for. And then the last one was 57, so we have a 7 there. So that's how a stem and leaf plot goes. We can also have a compound stem and leaf plot. So with this, your stem is going to be in the middle column, and then you're going to have a leaf on each side, basically, for each one of your data sets. So let's go the other way with this one. So we have the stem and leaf plot. Let's see if we can figure out what the numbers are. So just the main thing for this is that you want to read the data from the inside out. So we'll start with the males. So for the stem of 1, you would first pair it up with the 0. So that'd be 1, 0, which is 10. And then 1, 2, which is 12. And then 1, 5, which is 15. Do you want to show those numbers?
Yeah. So 10, 12.
And then you could move to the 2. So that'd be 21 and 25. Gotcha. And then for the female ones, you have, 1, 5, 1, 8, so 15 and 18, and then 21, 26, 29, and 29. And you'll notice that like you have a number that repeats, 29. You do need to put 2 9s. So each one is significant. And then if you have more than 2 digits, like let's say you had the number 132, in that case, then your stem would be the first 2 digits. So you would have a stem of 13 and a leaf of 2, and that would be the number 132.
Cool. Okay, now I get to play the misleading graphs game. So take a second and see if you can see what the trickster who made this graph is doing. If you look at manufacturers' automobiles, their competitors' automobiles, and competitor 2s, it looks like there's a huge difference between these 3 bars because of the way they've set up their y-axis. But if you look at the actual numbers, we have 98, 97, and 96, which if you look at percent of cars on the road, it's essentially the same. Although it's weird that it says percent of cars on the road. I'm not even sure what they're trying to get at here, because how do you have 98%, 97%, 96% of the manufacturers' automobiles, the competitors, and the competitor twos? Any idea, Karen? Just
No, I've never actually looked too deeply at it.
so maybe they're not like trying to be dishonest. They just don't understand how percentages work. I'm not quite sure. Okay.
Yeah, but the idea is definitely that you should start your y-axis at 0. If you don't, if you truncate it like they did on that first graph, then it can visually throw everything off and it'll make it look like there's a larger difference in the heights of the bars than there really is.
Cool. Okay, yeah, so starting at 0 is preferred. Now this one, they're zooming in on the years from 2011 through 2013. And it looks like they're going up, right? Significantly, the number of border apprehensions went up a lot from 2011 to 2013. Then I think you're saying that if you zoom out to a few years prior to that, you can see that the exact opposite trend has been going on long term. So maybe when you're doing longitudinal studies or showing data over a series of years, you should try to go back to give yourself a more full reference point. Unless you're trying to make a very specific argument and you want to swindle somebody, you can zoom in. Not saying that that's what they were trying to do.
Well, so that first graph did come from an article where they were trying to say that Southwest border apprehensions were way up during Obama's presidency. So that's why when you actually look at the real data and you zoom out to when his presidency started, you can see that that's not giving you, their chart was not giving you the full picture.
Gotcha. Yeah, specifically if you're going to cover someone's term, you should probably cover their whole term.
Yeah, exactly.
Okay. And then this one is great because the lower bar is 6 million and the other bar is 7 million. And I think it's trying to show a discrepancy between the goal and where they're actually at. And they have 1 million left to go, I guess. But 6 million is most of 7 million, right? So it makes it look like it's a quarter. Like it looks like they've reached a quarter of their goal when they've reached 6/7 of their goal. So
yeah, so they definitely should have labeled their y-axis, and they should have really started it at 0.
Right. And this one is awesome because when I'm looking at this, it's like, oh, when I first looked at this, I was like, oh, Florida enacted stand its ground in 2005, and holy cow, the number of murders went down. So that looks like it's pretty effective. But then when you said, well, what's wrong with the graph? And I stared at it, I'm like, oh, why is it upside down? So it looks like actually between 2005 and 2000 and let's say 6 or 7, the number of murders almost doubled from 450 or 460 up to over 800. So that's kind of fun. Where'd you get this from?
It was in a news article.
Okay.
And that's the thing, these things aren't policed. There's no rule. You're not going to get in trouble for putting a bad graph in something. So, the makers of these, they can use kind of a dirty trick like that where they actually flip the y-axis upside down. And to your average reader, they're not going to notice that. So they just look at the heights of the points and the lines, and it basically makes you think the opposite of what really is true.
It says the source is the Florida Department of Law Enforcement. I hope the Florida Department of Law Enforcement didn't create this graph.
Don't know.
And this next one is coming from a textbook or something?
Yeah, I think this was a textbook one.
I really enjoy the clip art, but here it's like, okay, the dairy department has a 4, the fish department has a 4, and the produce department has 3 pumpkins, and the fish and the dairy, they have the same number, but the graphic or the clip art they use for the fish makes it look like fish is way up. I don't know. I just think it's kind of funny that.
Yeah. So if you're going to use graphics, you want to make sure they're at least maybe the same size so that it doesn't, visually make it look different.
Okay. In this one, it looks like 2016 is like the leading year um, for a number of cars sold by the Acme car lot. And then next largest is 2018, and 2017 and 2019 is the smallest. Um, but then that's partially because the graphic they use is 3D and there's like a vanishing point, right? Like what's that called? The art majors can tell me. This is where I'm like always calling on students. The art majors should tell me what this is, vanishing point or something. But anyways, if you look at this from a different scale, 2016 and 2018 actually had the same exact number of cars sold, and 2017 and 2019 were almost the same. So here it's like using this fancy 3D graphic kind of throws things out of perspective. Do you have anything else to say, Karen?
Just that, like, if you're gonna do your own chart or graph, it might be tempting to take advantage of, fun little features like this, where you make it 3D and kind of skew it a little bit. But if it ends up distorting your data, then it's really not worth it to use those extra fun features.
Yeah, a good graph is supposed to make the data clear, not muddle it, I guess. And then, yeah, this one, okay, so it says that the price of milk went from $1.08 in 1988 to $3.50 in fall 2011. Why they're comparing those 2 years, I don't know. But also the milk bottle is like 20 times the size in fall 2011 than it is in fall 1988. So I think the graphic is not matching the numbers because it's 350 is only 3 times as much as $1.08, right?
Yeah, so mathematically, like, that milk carton should only be like 3 times the size, but because they expanded it in both directions, like the X and the Y direction,
Mm-hmm.
it makes the area look a lot larger.
Okay, and so these are some real ones. This is where time scales are screwed up, right? Because if you look at the world population in billions from this U.S. Census Bureau, it goes 1804 to 1927, so that's 122 years. And then the next time step is from 1927 to 1960, so that's like 33 years. And then 14 years, 13 years, 12 years, 13 years, 14, and what's that, 17?
Sure.
Cool. So I'm not sure what they're trying to show there, but it's not, I mean, you see exactly when we hit those times, but it isn't using a linear scale, so you don't get a real good perspective, I guess. And then the next one, job loss by quarter. It seems like you're picking on Fox News, Karen.
They made it easy for me.
Okay. I mean, well, you have some of the students send you these, right? Like they just see these and they're like, oh yeah, this is an example of a bad graphic.
Yeah, some of them have been sent to me.
Or do you watch a lot of Fox News?
Oh, I do not.
Oh, okay. So what's going on here? They just, the fact that they are not going quarter by quarter, they're just picking random dates.
Yeah, so when you have a time series chart, you should definitely have a scale that is even in between all the dates that you're using. Otherwise, you have to wonder why certain times are, why you're picking and choosing certain times.
Yeah.
So if you're going to do a time series chart, show all of the data in equal increments.
Yeah, this chart kind of like suggests that there's just this clear linear increase in job loss by quarter, but we have no idea what actually happens. Like, like after September 08, between March 09, you could have what happened um, in December, because that would have been maybe a job increase point, right? Like because there's usually a seasonal increase in December. So I don't know. And this next one, the cost of gas. I'm glad I'm not paying $3.57 a gallon anymore. But here, I guess, so are you picking in the time scale? We got,
Yeah, it's the same idea again with the time scale and the y-axis. Actually, they truncated the y-axis, and then the x-axis is not like equal.
and it's last year, last week, and current. So if I were to look at this today, I'd be like, oh, the current gas price is $3.57. The current gas price right now is like $1.80. So the y-axis wouldn't even capture the current gas price. as of today, but I'm assuming this came from like when, 2012 or 2013 or something.
Who knows? So it's not even labeled properly to where people in the future, if they look at it, they know when this chart, was made.
Mm-hmm. I guess, yeah, and it's funny that the time scale is the same from last year to last week is the same distance as last week to current. So 7 days,
I know.
same emphasis as an entire year. This one's really up to date, right? You said the student just sent this to you?
Yeah, a student just sent this to me like 2 weeks ago.
Man. So like we said, pie chart should add up to 100%. And so can you guys spot what's wrong with this one? So
I
most
know.
people are, what is it?
Yeah, well, I think 62, 68, and 48 adds up to more than 100%.
Right. So these are not, I guess they're taking a survey where they're not disjoint categories and then trying to make a pie chart with that, which just doesn't make sense. And this is the same sort of sin, right? There's just many
Yeah.
examples of where people do this, where pie charts, they put things together and they don't add up to 100%. The left one doesn't get anywhere close to 100%, and the right one is way over 100%. This is the same sort of thing. It's just on a pie chart, right?
Yeah.
Ugh.
Same idea. If you're going to use percentages, they should add up to 100, whether it's, on a chart or just in a poll.
And then this one, should Scotland be independent? 110% of people say either yes or no. So that's the only takeaway I can get from that. Okay, and this one you asked me about, and it took me a while to figure out what the big issue is, but it's like I don't know if they just wanted to make it look pretty and they don't really care about what the data is that they're reporting, but like it looks like Phantom of the Opera is doing about as well as Chicago. And then when you actually look at the colored bars, it's like Chicago did 3 times as well as Phantom of the Opera. It also looks like Rent is higher than Phantom of the Opera because you have this clip art guy or this, I don't know, Photoshop guy standing on top of the actual bars. Anything else?
Yeah, just that they went way too overboard with the graphics there, and it ends up distorting the data. So don't make your graphs too fancy or too fun.
Is this the last one? Are we done for this section?
Yes, I think that is the last one. So we're done with the section and the chapter. That's the end of chapter 2.